So our next presentation is all about how to build optimized geolocation solutions with Sigfox IoT network. So we're all used to finding things on the internet, but what about finding things in the real world? From packages waiting to be received, products in stores, to our own personal objects that we often lose, and not to mention the people that we love. Bit of a stalker thing going on there. Now, GPS can track locations outside, but what about inside of our factories, stores, and homes? Inside tracking is a challenge some innovative companies out there are willing to hack, such as Sigfox IoT. Now, Aurelian, our next speaker, is a sales engineer in charge of developer relations for Sigfox. He has a background in telecommunications in France where he worked for 6 years optimizing cellular networks, and he's currently been working in IoT since 2015. You'll hear in this presentation all the challenges that Sigfox solves across its network of 45 different countries and counting, and how you might like to use Sigfox technology. Can we give a warm welcome? Thank you.
Thank you. Thank you, Colin. Hi, everyone. So my name is Aurelian. Not the easiest name to remember, so that's why it's on the first slide. So I've been working at Sigfox for 3 years, where I'm in charge of developer relations. So I organize workshops in different countries to teach about the technology. And today we're going to talk about IoT and geolocation, and more especially how to build optimized geolocation solution with Sigfox. So before going deep dive into the subject, so when we talk about IoT with people in general, people think about this, which is like all the smart connected objects. So you could have like a smart scale, smartwatch. So some of them can be seen as gadgets. Some can be useful if you think, for instance, of a smoke detector in a house. And some a bit less useful, I mean, in my opinion. So this one, for instance, it's a smart salt dispenser, where basically you can use your smartphone to know like how much salt you want to put in your meal. So, do we need that? Maybe some people will agree. But in general, when we talk about IoT at Sigfox, it's more about industry. This is where the big challenges are, which is to really optimize industries. So for instance, it could be in agriculture to monitor the temperature and humidity of the soil in order to avoid wasting water. It can be tracking assets with containers, optimizing garbage collection in cities, and also detecting fires. So before I go further, just to get an idea, who has heard of Sigfox here? Just a few people, okay? Sounds good. So Sigfox, it's actually both a company and a technology that we have developed. So it's a global IoT network. And when we define Sigfox, we have like 4 pillars that we are talking about. So the first one is to be low power. So when we say low power, the idea is to get devices that can last without changing the battery or recharging for 5 or even 10, more than 10 years. So very low power technology compared to existing legacy ones. So it's a global network. We'll see in the next slide, but we are in 45 countries at the moment, and it's expanding to 60 countries by the end of the year. It's a low-cost technology. So low-cost meaning that, for instance, on the subscription level, if you want to connect an object to the Sigfox network, it's going to be between 1 and 10 euros per year per device connected. And it's also very cheap on the hardware itself. So you can buy a Sigfox module, which is like a modem to communicate with the network, for less than $2. And the technology is very easy to use. So like you don't need any SIM card compared to like cellular networks. Once you have a device, you can just turn it on. It will start communicating with the network. There is no synchronization mechanism. So it's very, very easy. So just to give you an idea of where we are at the moment, so like in dark blue, that's the current coverage. The gray one is what we are aiming for at the end of the year. So you can see that most of Western Europe is covered. You could see that Romania is not covered yet. But thing is, it's going to be covered soon. You will have main cities covered in autumn. We have a partner in Romania that is going to start the rollout here. We have good coverage in Latin America, in United States, in Asia as well, with Japan, Hong Kong, Singapore, Malaysia, Thailand. I forget some of them, I guess. And Australia and New Zealand as well. So the network itself, it's very simple. It's a very flat network. If some of you have done some cellular telecommunication, you'll see this one is very easy. Basically, we've got different base stations in territories. For instance, in France, we've got 2,000 base stations in order to retrieve the messages from different devices. And then the data can be transferred. It is first stored on the cloud platform of Sigfox, so you can access the data directly using a front end. And then you can push the data to your own application, so either directly to your own backend, or to third-party applications like Amazon Web Services, Microsoft Azure, or IBM Watson. So here it's just an example of an antenna that we have in Antarctica. There are not many people to cover there, but actually we have a foundation at Sigfox where we have like non-profit projects. And here we have a network to actually take care of scientists, because every year we've got scientists getting lost actually in Antarctica. So we are using the Sigfox technology over there to take care of missions. Okay, to go a bit more deep dive into Sigfox technology. So as I said, it's very low power, but it's also very low throughput. So if you are used to 4G, 5G is coming soon with like very high data rate. With Sigfox, you've got 100 bits per second, which is, as you can imagine, very low. And the way it works is that you can send some messages of 12 bytes. There is no IP header. It's not an IP communicated protocol. So you've got 12 bytes of payload where you can send your data. So it can be sensors data, for instance, for temperature, for humidity. It can be GPS coordinates as well. And we will see, like, for instance, for GPS, you don't need more than 6 bytes to send coordinates. So it may seem pretty small, but when you start optimizing your application, with 12 bytes, you can do actually a lot. Okay, so let's look into like an example that is pretty common for us. Tracking and logistics is a big use case for the technology. So if we look at an example where we want to track a container across the world, so for instance, you can imagine having containers in South America, in Brazil, that are used to store, to send fruits overseas. So most likely you will have the container to be transported by boat, for instance, to Netherlands, to Rotterdam, which is like a big harbor in Europe. And then it will go, for instance, to Munich in Germany using rail. So if you want to do that, most of people would say, well, we'll use GPS and then some communication network, like cellular network, in order to send location information. But GPS got few drawbacks. The first one is the cost, because you need to add a GPS chipset on the device itself. So it's an additional cost, and for some use cases, it doesn't make sense regarding total cost of ownership to get an additional GPS chipset. And the battery as well. GPS is drawing a lot the battery. I mean, I'm sure you know, like when you are using Google Maps or any navigation on your smartphone, the battery is being killed very fast. So the other thing that you need to also get in mind is that, do you really need GPS? Do you really need to get like a 10 meters accuracy for this kind of use case? For most of companies, what they want to know is that, does the container reach my city? Does it reach the harbor? So you don't need a very precise, accurate location. And so this is where Sigfox geolocation comes. So Sigfox is first actually a network where you can transmit data. But we've got also a geolocation mechanism where we do some triangulation with the base station in order to get global accuracy of where the messages, where the devices are located. So the good thing about this is that you don't need additional hardware. You just need the Sigfox modem to send the data. And all the computation of location is done into the network. And then the location information, you can retrieve it in the Sigfox cloud and send it to your web servers using HTTP callback. Or for demos, we usually use emails, which is like very simple. You just receive an email with the location of your device. So here I just got an example where I am in Paris. I can show you directly on the real backend. I need to switch. Okay, so this is just basically this small device. That's the only hardware that we do at Sigfox. It's basically a device that sends temperature, humidity. There is also an accelerometer, so you can put it, for instance, on your door. And if the door is getting open, you will receive a notification. And I always carry this sensor with me when I travel, and so I can see where basically I'm going. So if I go here, for instance, and go back to the 14th, so it was 2 days ago. It was when I was in Paris, so yeah. So you can see that's around the location of the Sigfox office in Paris. So it's not very accurate location, but for many use cases, especially in logistics and asset tracking, it's way enough. So second thing I want to show you, it's on this platform. So this platform is actually an open source platform developed by 2 engineers at Sigfox. So you can get it on GitHub. It's free to use, and feel free to do pull requests on it. And basically I use it to see where I am going when I travel. So like recently, here it's just the history of my device from May 1st to May 16th. And so I had some good holidays in Portugal 2 weeks ago. I went to London, yeah, it was 2 weeks ago as well, and Newcastle, with a stop with a layover in Amsterdam. And this one is actually my trip here to Romania. As I said, there's no network yet in Romania, but I actually had a layover in Munich. That's why I've got some signal, one message here. And this signal and this one, it's just actually I forget to turn off my device in the plane. And so messages were received by the network when I was flying over Germany and flying over Hungary. So probably we should keep that between us. It's probably not very legal, I guess, to send messages in the plane. But okay, so it's just to give you a whole idea of what you can do with the Sigfox geolocation. Okay, let's go back to the slide. Okay, so I could show you as well on the back end directly the configuration of my callbacks, but basically every time a message is being sent by my sensed device, I receive an email with a link with a Google Maps, so I know where I am because usually when I travel I know where I'm going and I've got my smartphone, but it's just to show the capabilities of the technology. Okay, so we've seen how to use Sigfox for geolocation, but for many other use cases, you also need to combine it with other technologies. So if you need to get very accurate data to do some, I don't know, like to track your car, for instance, GPS will be useful. Like you don't want to know that if your car is in like 2 kilometers radius, it's not very useful. But the good thing is that Sigfox works pretty well with other technologies. So if we look at the wide variety of location system, so like on a local network level, you've got the RFID that I use for badges, for instance. Bluetooth, that is pretty common, for instance, for indoor geolocation. So where you can put like beacons inside factories, for instance, and when devices are going through the factories, they can know in which areas they are based on the beacons that are located there. Wi-Fi is a pretty good technology, especially like in urban environment. So for instance, we've got like big databases with Google or other provider where you can get geolocation data when you send access point MAC addresses. So it's really good for cities geolocation. And then we've got cellular networks and Sigfox with a few kilometers accuracy, and GPS with a satellite infrastructure which got the best location information outdoor. So here's just some example of one of our clients, so Louis Vuitton, which is doing like luxury accessories. It's a luxury brand, so they do like luggages. And recently they have released this device, which is like a tracker that you can put into your luggage. And it's mixing Sigfox geolocation and Wi-Fi geolocation. And basically the idea is when you are flying and you go from an airport to another, you want to be sure, you want to check that your luggage has arrived at the destination. I mean, when you travel a lot, I'm sure it happens to some of you that losing the luggage is kind of a nightmare. So you've got an application and you can check where your luggage is located using both Sigfox geolocation and Wi-Fi. So how it works regarding the Wi-Fi geolocation. So I've already mentioned it before, but basically you've got big database providers. I mean, the most known one being Google. So because like if you're a developer, it is free, you just go on their API, and what you need to do basically is just to send 2 MAC addresses of the access points that you can scan where you are located. And thanks to that, you will get quite a good location, especially in cities, so between 10 and 50 meters accuracy. Actually, if you are in cities with like very high buildings, you may get better results with Wi-Fi compared to GPS. So it's something to keep in mind. And last thing I wanted to say is 2 MAC addresses, it's 12 bytes, and the size of the payload of Sigfox is 12 bytes. That's pretty good coincidence, I think. So the way it works is that then you capture the 12 bytes for the 2 MAC addresses and you send them using Sigfox network, and then into the Sigfox cloud, you just call the Google Maps API to get accurate geolocation information. So here's just some example code with one dev kit that we have from PyCom. Some of you may know PyCom. It's a pretty good company that are doing some development kits. It's based on the ESP32. And good thing about this chip is that you can program using Python, I mean MicroPython. And here's just an example of configuring Sigfox and sending SSID, MAC addresses over the network. So as you can see, it's like just a few lines of code. It's quite simple. You've got this function on the left where basically what you do is just sorting networks that you have scanned and retrieving RSSI information. Okay, so another example that we have with different technologies. So we have talked about Wi-Fi, about Sigfox. That's one of our partners, Sensolus, which is working with Airbus. And what they are doing basically is that they want to track the spare parts of planes and other equipment. And to do that, they are mixing GPS and Bluetooth. So what they do is that when the parts are outdoor, they are using the GPS and sending the coordinates using the Sigfox network. When the parts are indoor, they've got some beacon system where basically they are just scanning the beacons and sending the information using Sigfox as well. So this use case is really to optimize basically the supply chain of the company. Okay, so we haven't talked yet about combining Sigfox with GPS, but they work well together. As I was mentioning before, to send GPS coordinates, what you just need is basically 6 bytes. So if you look at latitude and longitude information, so here's the one you have here like 46.23. So that's basically the location of the hole here. And when you go on Google Maps, you will see you've got tons of decimals for the coordinates. But if you go into the details, basically if you look at the 4th decimal, it's around 10 meters precision. And 10 meters precision is usually way enough, because if you look at the GPS datasheet, the GPS chipset datasheet, the accuracy will be between 5 and 10. So you don't need to go to get more than 4 decimals. So here just got a bit of math, nothing crazy. But basically, if you just need the 4th decimal, what you need to code the coordinates is just to go from minus 99.9999 to 99.9999. So it's around 2 million possible values. And 2 million possible values, you can code it easily on 3 bytes. 3 bytes being 2 exponent 24, so it's 16 million. So you've got way enough space to code coordinates on 3 bytes for latitude and 3 bytes for longitude. You could even go lower, probably to 20 or 20 bits for each coordinate. Okay, one last thing regarding GPS is battery consumption. So as I mentioned before, battery consumption is a big problem with GPS chips. So if you look at a data sheet from a GPS, so the one on the top, the big issue is what we call the cold start. So it's when you start the GPS device, it will take like around 30 seconds to acquire the satellite's information. So 30 seconds is quite big. So what you can do, so for instance, if you are doing some containers tracking, probably what you need is sending a message every hour is way enough. It's not moving very fast. So we've got some companies that are actually moving positioning algorithm in the cloud. So they still have a GPS chips, but some of the computation is done in the cloud instead of on the chip. And with that, they can reduce the cold start to less than 10 seconds. So it's another way to optimize GPS battery consumption. Okay, so it's just one last thing regarding geolocation technology. So we've got this great partner who is doing a module with Sigfox GPS, Wi-Fi, BLE, plus an accelerometer. So if you have a project and you want to start doing geolocation projects, this one is really nice. Good thing is that it's compatible with GCC, so you don't need to buy like a very expensive cross compiler. Cross compilers in general, the one for industries, they cost like a few $1,000s, so it's quite expensive. And you've got the source code available on GitHub. Okay, so if you are interested to start working with Sigfox, usually the best thing is to get a development kit. So we've got development kit with Arduino, so like official boards with Arduino that you can get. I mentioned the PyCom already. This morning there was a guy talking about Raspberry. We've got also shields for Raspberry. So it's very easy to start working with Sigfox. As I mentioned, there's no coverage yet in Romania, but the main city will start to be covered in autumn. And if you wish to start even right now, we have a solution with this SDR dongle. So it's basically emulating a base station. It's not connected to the real backend, but it will emulate a base station and a backend. So if you want to build your own device, it's a good tool to start with. And if you have any question or anything, you can go join our community. So we've got an Ask forum, we've got a Slack as well. And last thing, so I have put my coordinates here, so my email, and I've also put the email of one of my coworkers here in Romania. So we've got a country director based in Bucharest. So if you have any IoT projects and you are interested in Sigfox, you can definitely contact him or contact me as well. Thank you, everyone.
So, any questions from the audience? Any questions? We have over here.
Yes, so you were saying that part of the computation is moved to the cloud. How do you transmit the information if you have such, let's say, a low bandwidth? Because you're going to need to transmit a lot of stuff to move the computation.
Yeah.
Do you mind just repeating the question for the audience so everyone can hear?
Yeah, so the question was about the example about the company moving the positioning algorithm in the cloud. So how can you send information with just a 12 bytes payload? So the partner I mentioned, Ubiscale, I mean they don't disclose the algorithms they have. What I can say is that they just use 11 bytes to send the data. So some of the ephemeris computation will be deported on the cloud, and they are just sending 11 bytes, and the computation will be done in their servers. So, and it's working pretty well. We've got already some projects with clients using this technology.
I think there was a couple more questions.
There was, yeah.
Over here. Do you mind if I?
Yeah.
What's the cost of this device and the use of the network?
The device?
The use of the network. What's the cost of the device and the use of the network?
Oh. So when you do Sigfox, you've got the price for the subscription, because you need to access the network. It's between 1 and 10 euro per year per device to access the network. Other thing, otherwise, is that if you are using a dev kit, so like the Arduino, PyCom, or any Sigfox dev kit, it comes with 2 years of free connectivity. So for instance, the Arduino, it costs 35 euros, and you've got 2 years of free connectivity in the 45 countries where we are. So one thing I haven't mentioned is that we are in 45 countries, and the roaming is completely free and transparent for you. So if you have a device here in Romania and you move to Germany or France, it will work the same.
There's a question over there.
Hi. How small is the battery for the device, as in minimum?
The battery?
Yeah, as in minimum size.
I mean, the battery size really depends on how long you want the device to stay up. Like depending on how many messages you send, so how many messages and for how long you want it to get running. But basically, if I look at this device, it's a very small battery. It's a 250 milliamp hour, and I'm sending a message every hour, I guess. And after 2 to 3 months, it will be dead. It's a very small one. If you want a device to last for 10 years, you will go to get a few thousand of milliamp hour to get it running. But it's just, I mean, electrical computation. It's how many messages you want to send and for how many days, how many years.
Any other questions? No? Thank you very much, Aurelian.
Thank you.
Cheers.
Thank you, everyone.